Let's look at adding vectors graphically. This is Chapter 5, Section 5.1. And this is when I want you to use a ruler and a protractor to add two or more vectors together. So here are the steps. Draw one of the vectors to scale. You can set your own scale. Then you draw the second vector by placing its tail at the tip of the first vector. Be sure to place it in the correct direction. You continue in this manner until all vectors are drawn. Again, you can connect two or more vectors to get the result. You find the resultant by drawing from the tail of the first vector to the tip of the very last vector, and you find the length and direction. So let me show you an example. I would like to find the resultant of two vectors. One is 10 newtons east, and the other is 25 newtons south. My scale, 1 centimeter equals 5 newtons. So my first vector that I drew with a ruler is 2 centimeters in length, and I'm pointing it towards the east. My next vector is 25 newtons south, so I drew a vector that's 5 centimeters in length, pointing towards the south. Notice the tail of the second vector is on the tip of the first vector. Now, to find the resultant, you draw from the tail of the first vector to the tip of the last vector. We're not using Pythagorean's theorem here, even though we do have a right triangle. I want you to use a ruler and a protractor. So if I measure this length, it's about 5.3 centimeters, which I can convert back to newtons. 5.3 centimeters times 5 newtons is represented by 1 centimeter. My centimeters cancel, and I have 26.5 newtons as the resultant force. My direction is measured with a protractor, and it's 68 degrees. So even though we can do it algebraically, I'm teaching you how to do it graphically because the angles won't always make a right triangle. And it's just one of those skills you should have. Another thing we need to do with vectors is to take a resultant and go backwards and find the x and y components. So finding x and y components. My example would be to find the x and y components for the vector 75 newtons at 40 degrees north of east. East, huh? All right. So you're going to draw the vector in the proper direction, and you're going to draw the x and y components of the vector with their tips, and you're going to use SOHCAHTOA to find the lengths of each component. So, there's my vector, there's my x, there's my y. This angle is 40 degrees. So from my first step, my cosine, SOHCA is adjacent over hypotenuse. My hypotenuse is 75. Make sure you're in degrees when you use your calculator. Your x is 57.4. Just checking my math. All right. Now, we also need the direction. My x is pointing towards the east, so my final answer for this is 57.4 newtons at east, or east. To find the y, we just need the sine function, and the sine of the 40 degrees. Sine is opposite over hypotenuse. Calculate your y value, and you get 48.2 newtons, and this time it's north. And that's how to find x and y components. We'll be doing some of this in class tomorrow.